is learning calculus from me right now. Probably not. I don't know. I like to think that. All right. So at any rate, I get 1/2 inverse sine of x plus subbing back for these signs. Pretty easy to sub back for. What sine? That's x. That's no problem. The cosine, yeah, not so much. What I can tell you definitely don't put there is cosine of arc sine. No, 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 no. Okay? To sub for this, you draw a triangle. A lot like you did in the arc cosine derivative lesson in 66. If x equals sine theta, then sine theta equals x over 1, and that's the opposite to hypotenuse ratio by definition of what sine is. The sine of an angle is the ratio of its two sides. So in this case, theta is the angle, opposite side is x, and a hypotenuse is 1. Now if I want to find cosine, I need adjacent to hypotenuse. So what is the adjacent side? Square root of 1 minus x squared by virtue of Pythagorean theorem. So what is cosine theta? Adjacent to hypotenuse. Square root of 1 minus x squared. Got it. And that is all she wrote. You follow? All right. Now, there are really just 3 trig substitutions you make. You either use sine, tangent, or secant, depending on what the square root or the Pythagorean theorem part looks like. We never use cosine, cosecant, or cotangent. So we just did sine. Let's try the other 2, tangent and secant. Okay. Is this the right next problem, Mike? The slides are open. Yes. Okay. No, it's not. Is it tangent?
Yeah, it's tangent.
Oh, okay. My board's all messed up here. All right. Is this right? Okay. So the substitution. Some of these are easier than others. Let's go here. Substituting in each. X is going to be replaced by 4 tangent theta. That's the one they're telling you. Everything else needs to be found. What's dx? For secant squared theta d theta. And what's x squared? 16 tangent squared plus 16. Okay. Now, if everything goes well, the root especially should clean up, but a lot of other stuff cleans up too. Altogether, numerically, what happens with all the 4s and the 16s? At the end of the day, what's the number I can pull out front for a coefficient? 1/4. I agree with 1/4. Those 4s drop out, square root 16 becomes a 4th in the denominator, right? Or a 4th. Okay, I'll leave secant squared. D theta. I'll leave tangent. What about the root? How does it simplify? We pulled out the 16, so it's tangent squared plus 1. What's that identity plus? Secant squared. So that becomes secant squared, which is square rooted. So when I pull that square root out and dump it, I lose a secant. Yay? All right. Now, this still isn't super clear, but we're making headway. I still don't see it. So what should we do? Sine cosine. Sounds good. So 1/4. The secant would become a cosine, and the tangent, you could put it in the numerator, or you could just leave it there and call it sine over cosine. But I feel like cosine's going to drop out. Okay? All right. So that, then, is the antiderivative of cosecant. In case you're rusty, I threw those off to the side for reminder's sake. What's the antiderivative of cosecant? Natural log of the absolute value of cosecant theta minus cotangent theta. The c's negative in there. All right. Now we have to do a little subbing back. The subbing back involves picturing the relationship. 1/4 log of. Let's go back to the original substitution rewrite it a wee bit to call it x over 4 is tangent theta. I want to isolate the trig and have a side ratio on the other side, so that a triangle can be made, and tangent is the side ratio of TOA, opposite over adjacent. So opposite is x, adjacent is 4, which means the hypotenuse is the root of x squared plus 16. That's a lot like in the original problem. That will happen. That's to be expected. Now, then, we have all we need to find cosecant and cotangent. What's cosecant? Hypotenuse over opposite. Yeah, sine is opposite to hypotenuse, so cosecant's hypotenuse to opposite. So root x squared plus 16 over x, yeah? And cotangent, you could do the triangle, or you could just take the reciprocal of the tangent equation. If tangent is x over 4, then cotangent is 4 over x. The triangle would have got you. Let's see, and boom, that's it. All right? That one's pretty gross. That doesn't get, they don't get too much harder than that. Let's try one more, and then we'll try one off the homework, I think, instead of just doing the cheater chart. So, this bad boy. Try it on your own, and let's see how this is going. Then we'll try one off the homework. Do this right, the antiderivative should be really easy. It was square root.
Oh.
Yeah. So that's even better. So, again, it's really easy to sub back. You don't even have to draw the triangle. 1/3. Actually, I didn't go too fast, sorry. Are you going okay? So I got 1 in the integral, which obviously the antiderivative of that is theta, for integrating with respect to theta. Summing back for theta then, theta is, solve that equation for theta. Inverse secant of x over 3. And that's all sure. Okay? Now, we'll do one off the homework, but this is actually kind of important for a certain problem we've been doing lately. What's that? That arc length, okay? To evaluate arc length without a calculator, you kind of need trig sub. It's the skill you need to do that kind of problem. So they go hand in hand. We'll do that second semester also. Would you go, rather than do the U-try, the students on the fifth said, let's just try 21 on the homework. So go to 21 on the homework, which is a replacement problem. That's a trig sub problem. Try that.
Oh, nice.
cotangent squared in the, sounds good. That you've done, you should know how to deal with that. You agree with something like that? So?
Yes.
Okay. Yeah, one yes.
Wait.
Not negative? Not this negative?
That is.
Isn't the antiderivative of cosecant squared negative
Yeah. No, I got that.
Oh, is there another negative I should mention?
No, I apologize.
What was your identity for cotangent squared?
1 plus cosecant squared.
Cosecant squared minus 1. Okay, so that said then, I think, I'm pretty sure that's right. 88% sure.
Where did you get the H15 minus the square?
So actually, I should show my work up here, sorry. So my work looks,
Just feels
oh, do I, yeah, no, that's right. Oh, so the triangle, so your triangle was sine of theta equals x over 5, yeah? You agree?
oh, yeah, I messed up the square root.
Okay, okay, cool. Okay, that's that. Questions on 110 and or 111? I will do them in whatever order you got. 110.3. 110.9. What? Okay. Boom. Okay, so 110.3. Okay.
Oh my God, no.
Okay, I'm with you. All right, so 110.3. The vector of length 4 that's normal to 2, -3. Vector magnitude equal to 4, normal to 2, -3. Okay, so I'll do this part second. Let's do this part first. What's a vector normal to? 3, 2, exactly. Switch and change one sign. So 3, 2 is the most logical way to go. Okay. Now then, that right now, that's too long. So we shorten it to 1, the unit vector. How do we shorten it so it's only 1 unit long? divide by the magnitude. The magnitude of that by Pythagorean theorem is root 13. So by dividing each component by root 13, for that scale factor, it'll make it 1 unit long. Now we stretch it to 4 by multiplying every component by 4. So 12 over root 13, 8 over root 13. If this were homework, I'd probably just roll with it, but if this were test and my life depended on it, I'd probably verify by Pythagorean theorem that magnitude is 4. Okay?
Oh my god.
Alrighty. Which one?
22.
On 110?
No,
Okay.
this is so funny.
We can wait till you do 9.
What about it?
You can do 9 first.
Oh, okay, got you. 9. Check. I'll put it up 110, 22, 110, 9. Okay. And 21? Okay.
17.
And 17. And these are all 110?
Yeah.
Okay. All right. 110.9. I'm glad you asked. This is a good question. I'm glad he put it in because I can only put so many examples into my notes and I can't get every idea possible. But this is important. Minus 0.87. All right. Now, in the notes I told you could use X or Y to find arc length. And this is not a function of, this doesn't scream either one solved for, so you have choices. But there's definitely a better choice than, one's better choice than the other. I would definitely not solve for Y. Because if you solve for Y, that would involve plus or minus. And that's bad. I don't want there to be some ambiguity. Now, you might say, wait a second. I can see that the plus or minus wouldn't be an issue because it's obviously plus. You don't know that. You don't know that it only stayed positive. You don't know that. That's a lot of gray area. And so that is to be avoided. The plus or minus that could come with solving for Y, you don't want to go there. This, that's better. A cube root isn't plus or minus. So you should cube root. And so it would be y plus 1 to the 2/3. This, again, that graph, you have no idea what it's look like. It's called a closed curve, and it could look like this. It's not a parabola. It's not like anything you know. There's too much gray area. So avoid the plus or minus by using the cube root. So x is 4 plus y plus 1 to the 2/3. Now in terms of arc length, our equation is in terms of y, so our arc length is going to be 1 plus the derivative of a y function with respect to y. And so the limits in y have to be what to what? 0 to 7. Okay? And so the derivative, I take the derivative of this dx dy, I guess if you like, that's pooping me out. But dx dy is 2/3 y plus 1 to the negative 1/3. After that, you can use your calculator. You can use your calculator. Do we have an issue with discontinuity there? Where's the discontinuity? At y equal negative 1. Now, had that domain gone negative 2 to 7, you're in deep duty. You've got an improper integral. There's a vertical asymptote in the middle of your quantity. That's a whole nother ball of wax that we'll talk about second semester. But you're good. It's continuous, so you're fine. Okay. 110.22. Is 110.22, that's you, yes? Okay. 110.22. I'm listening. When you did it?
I like dropped down to 3x squared minus x plus 10 instead of 2.
Oh.
And that's imaginary.
It was not factorable, right?
Yeah.
Yeah, I just kind of,
Let me have this moment, okay?
I just kind of wussed on this. So I found the critical numbers by doing the quadratic formula and that stuff, but I'm not plugging that into the function. That's crazy. So let me just say what I would want to see on your paper, okay? I would like to see that you didn't just do the whole thing in your calculator. I would like to see some calculus. So something like the extreme value theorem, absolute extrema at an endpoint or a critical. The endpoints you're given, I think -1 and 5 if I recall. The critical numbers are where the derivative is 0 or undefined. I would like you to show me the derivative. Basically, I'm trying to get you to guard against being too far gone from your calc basics. I know it feels like kind of in our head that, oh my God, we can do a derivative like that, no problem. Remember, you're going to be tested in May, after you've been doing calculus for 1.5 years, on the most basic, take the derivative of that kind of question. I mean, that'll be on the BC exam, something that easy. You can't be so far past the basics that you forget. So I do want you to practice this. This you said is x cubed minus 7x squared plus 10x, yeah? Okay. So the critical numbers then, the derivative at least. So to me at that point, if you picked up the calculator and said the critical numbers are these by calculator, if you use the polynomial solver in your calculator or whatever, and then you said f at each of those candidates in your calculator, that's fine. I mean, they were hideous. They were not factorable. So does that answer your question? Okay. 21. 110, 21. This is a good one. I talking to somebody in 7th period yesterday. I'm not quite, I need to probably review end behavior / the dominance of functions, all right? Okay. Yeah, and I will review it, but just so we're clear, if I give you this problem, which wins? The top wins or the bottom? Top wins. Okay? Doesn't matter that it's barely 1, it's exponential. And exponential always wins over polynomial. I don't care if it's x to the trillionth power. It loses to exponential, assuming the base is greater than 1. That goes to infinity. All exponential with base greater than 1 dominates. Now that said, what about this, something exponential versus factorial, which is a really important part of calc 2. Okay, I know it feels like that's a little probability. No, that's not a little probability. I think it's a big calculus. Which wins? Okay, so imagine 10 to the 10th, then 10 to the 11th, or A10, A9, A10, and 11. That's what'll tell you the whole scoop. A10. I wish I would have chosen something else besides 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 8, 6, 1. All right. Now, A10. How will it be like A9? What will change in the top? You got another 10. What changes in the bottom? You got a 10, all right? So at that point, the exponential is starting to tie. And the next thing, A11, is A9 times 10 tenths. And what's now in top going to be gained? Another 10, but now what's on bottom? Oh, factorial wins. Factorial wins because while the top always continuously gives another 10, the denominator is giving another greater number. And so the factorial is more powerful. More powerful than both of those is that factorial. That's the mother of all. Actually, this is the mother of all, or this is the, but those are the most. All right, all that said, in 21 is 2 to the n over 3 to the n, yeah? I would suggest, now, you can look at this two ways. One is to say, which grows faster, 2 to a power or 3 to a power? Another way that I think you'll do in second semester is that. It's 2/3 to powers. And as you take 2/3 to more and more powers, 2/3 of 2/3 of 2/3, what happens to the quantity? It gets, so it goes to 0. The limit of the terms is 0, so we conclude convergence. Okay? Okie dokie. Are you with me? I have 2 minutes. What about 17? Is 17 still a question?
Yes.
All righty. 17, let me fill these homeworks. Did I talk about a few things on the homework I wanted to talk about? Did I say anything about homework? There's a couple things today I wanted to talk about. Yeah, more today. I'm hoping that these start to get better and I don't have to start keep taking off so much. But I will. All right. Sorry, I'll come to 17 in a minute, but there were 3 things I wanted to talk about from things I saw in the homework. This will be pretty common second semester especially. I'll look at your homework and say, hey, you need to see this. One thing is this. Look at this guy. I think was this a problem on the front side, maybe on the left side? We call this down, converting this to polar. Does this look familiar? All right, well, never mind then. Here, just focus, okay? When you convert this to polar, most people make a substitution. R sine theta equals 2 r squared cosine squared theta. You with me? Check. It is common and expected that you solve for r. Unless the problem says you don't have to, it's expected you solve for r. Now then, the temptation is for students to say, well, can I divide an r out? Yeah? Yes? All right, now, here's the thing. You have been taught so well that you are rightly wise to be wary of dividing a variable out. In Algebra 1, for example, the minute you are given that problem is the minute 90% of the students said, oh, boom, divide out an x. And is that good math? That's bad math. Why is that bad math? You just lost a solution. If you divide out an x, you just lost a solution. The proper way to do it is to get all one side and factor so that one solution is not lost. But the 0 is always the one that's lost. All right? Now, so you're right to think, I'm not supposed to do that. The reason it is okay here is that you're not solving this for all possible r's. You're just trying to graph or get an equivalent equation. If you divide this r out, you're losing r equals 0. But I will show you that's okay. Sine theta is 2r cosine squared theta. R is sine theta over 2 cosine squared theta. Now, that's still defined at r equals 0. When theta equals 0, r equals 0. So that isn't a solution being lost. It's a point on the graph that's still there. And so that is okay. This is, I know it feels like it's not okay. It's okay. All right? I'm telling you it's all right. Second, parametric equations. Oy, oy. I think it was x equals 3t. It was on the back, like maybe 21 or 22 on set 107. Maybe it was 108. maybe it was 108.
Is there a pen metric on the back here?
Okay, bear with me though. It was on 108, but I haven't finished recording yours yet, so t squared plus 1, okay? The question here is threefold. Graph, find dy dx, eliminate the parameter. This is going to be on the test tomorrow, and I'm feeling like if things don't get a little better, you're looking at, typically most people will get 2 out of 5 on these. So if a problem like this comes, I would expect you to, first of all, the order in which you do things is up to you. And if you graph it first, you're going to have to make a table. There's no need. Do this first. If you do this first, then when it's algebra based, you do this by substitution. Right? Oops, that's a 2. T. Okay? Are you with me? All right. Now, the reason you might do that first is because you know how to graph that, but be careful. That is a parabola shifted up 1 and y, right? All right. Now, though, you have to understand that there are small differences. I will tell you, I haven't always remembered to put it in the box, but it is generally accepted that you only work with positive time. I think in the back of the book, the key is sometimes had the parabola as if all. That's not common. Most books say positive. All right. Now, if I had done, I think I did that on set 108, and I will do it on the test. But if you assume time is only positive, then that restricts x. X can't be negative if time is only positive. X has to be greater than or equal to 0. So in parametric, when you eliminate the parameter, you also give a domain or a restriction based on that time component. You follow? When you go to graph it, you're not going to give the whole parabola. You're only going to give that. So the graph is going to differ in 3 ways. First of all, it'll be domain restricted. Second of all, you're going to communicate where the starting point is, which is time equals 0. And I'm having most people forget that. And then the direction. And half of you are still forgetting that. The direction is that way. Okay? Are you with me? After that, all I have to do is dy dx, dy dx. Most people are doing okay, other than the occasional person not labeling their work, which is still fairly frustrating. But dy dt, that's something. All right? Most people do. I just wanted to make sure. 110.17. Sorry, I got off track. 110.17, is that a question? Somebody asked it.
Yes.
Okay, 110.17. How many 111 questions? Okay. All right, that said, then, good intro. 110.17. Where am I lost it. There it is. Find dy dx, graph dy dx, and eliminate the parameter. Okay, let's add into the condition that time is positive, okay? So, if I eliminate the parameter, how would you do that? I can think of a couple different ways to dump the t. When I say eliminate the parameter, you want to tease the parameter. You want to dump t and get x and y related. So, how do you do it? What's one way?
Set t equals natural log.
Okay, that works. T is natural log of x. If that goes in there, y is e to the -3 natural log of x. Now, that you have to be on your game to clean up. You know what's going to clean up. You got to figure out how to get the cleanup done. Let's switch the order first. E to the log of x times -3. An exponent rule is that a product of two is like a power to a power. Those are equivalent. Now you're good to go. e to the natural log of x is x. And so x to the negative third with a domain restriction. What's the domain restriction? If t is only greater than or equal to 0, then x is only greater than or equal to 1. Okay, e to the 0 and more, which means 1 and more. Okay, in terms of graphing, y equals x to the negative thirds is obviously 1 over x cubed. It has that same doopity-doo shape, same asymptotes. It still has the point 1, 1, like all those. The only difference is it decays faster. So it would decay faster this way, and we say this is the initial point and the direction is that way. And then dy dx is probably easiest to find. Oh, sorry, dy dx is negative 3 to the negative 3t over e to the t. Or if you like, negative 3 over e to the 4t if you put those two together. Yes? No. I will be here till 4. So good question.
Jordan Jeske, Alaka Granat, and Emma Rickman to the financial office. Jordan Jeske, Alaka Granat, and Emma Rickman to the financial
You
office.
could, it's more common to find it in terms of t. Okay?
So, I got double the answer in the back of the book, like exactly double. I don't know where the 1/2 comes from, but
Okay.
because it's solely for squares.
Oh, to get rid of class. We are.
It's almost like you should have used electrical tape on the electrical
Wasn't gonna break. That was the plan. Good plan. Plan didn't work. I burnt the tape.
Mr. Aikman, you should set the desks up like you had them last year. You had them in these like weird circle things.
Oh, I like circles.
Circles?
Yeah, there was some kind of like circle thing. I don't remember what it was, but it was nice.
Those are my favorite.
Oh, I'll have to look at all my plans. I have lots of
You should do one that involves circles.
Do it by parts. You could do it by parts or use it. I think try the other way around. Go, this is dv, and v is x. If you say, mu is root of 4, and dv is x. Oh, no, sorry, the other one. U is x, and dv is root of 4. Du then is dx, and dv is 2/3. So it becomes u times
Hello, I have a conclusion.
try the other one. Yeah, sure.
I'm complicated too.
Sounds good, thank you.
I'm signed up.
Okay, gotcha. I will not mark you up. There are 10